Oh, November 10th, I just finished work. Let's get this done. Or, well, just copy and paste. Size Zn, non-negative integers. Apply some operation to the array so that all elements become 0. In one operation, you can select the subarray and set all occurrences of the minimum non-negative integer in the array to 0. Return the minimum number of operations required to make all elements 0. So select the subarray with the minimum non-negative integer is 2, setting all occurrence of this to be 0. So it's 1. This I can set this, get 0. I can set this as 0 and this 0. Or yeah, I can say 1, 3. Yeah, 1, 3. And then we can do this and can do this. We can of course do this because you can take any I and j. Alright, you can take I can take the entire thing and then take the entire thing and then take the entire thing. Because the smallest in the turn 0. So this I take the entire thing, that will turn 0. 0, yeah, so it'll be this. But then I cannot take the entire thing because you have 0 already, so you have to take individual. It'll be 1, 2, 3, and 4. Okay, so the first step, you want to find the smallest, right? You turn the smallest into 0, okay? Because otherwise, yeah, that's the best to do, is to turn the smallest into 0. But once you turn the smallest into 0, and then you might split them up. And the 0 you cannot do. You have to find the subarrays that are not 0, right? So essentially, you have this array, 0, A1, A2, AN minus 1. You find the one, you notice these are the smallest, so you turn them into 0, right? And then that's the first. The first step is check what's the smallest, and then you'll have subarrays separated by the smallest. The smallest would become 0 first, and then you have these subarrays, and then you just do the same thing on the subarray. How many times we're going to do this, I don't know for sure, because within the subarray you'll basically do the same thing, right? You find the smallest. I wonder if there is a easier way to do this. What if we sort them, right? So you sort them, you have the value and you have the index. Okay, so you have a bunch of this. Then the first, these will be the first one, so they will be gone, right? And then you have the next smallest, but you don't know if they are in the same range, right? You don't know if they're in the same range. Yeah, I just know they're indices, but it doesn't help. Okay, we scan once, get everybody's position, and then you do, yeah, subarray, okay. And then given this, how do you know which one is the smallest? Basically, we want to know which one is smallest in this range. Which one is the smallest in the range? Come on. Come on. Oh, yeah, segment tree this one again? No way. But if you don't do that, you have to read through the whole thing again. And again. And again. Right? Basically, the first round, you need only one to get all the smallest. And then you're breaking the array into subarrays. And then within each subarray, the smallest can take it once. And then break into even smaller subarrays. So we start, we go, boom, we hit another smallest. How do you know it's even the smallest? You don't know, right? You don't know it's the smallest. But as we go, we can keep track, and then let me think. If you encounter something that's smaller than you, then you definitely getting separated into your own island. I'm actually thinking about maybe we can do monotonic array. Let's think about like if we do a monotonic increasing, right? So you get a small value, and then you get a bigger value, and you get a bigger value, and then you get a small value. So this small value guarantees that this is separated, right? So it cannot be, it cannot join with somebody else, right? So I'm thinking like maybe 1, 2, 4, 3, right? If that's the case, you have a 3, so which means this 4 is bigger than this, it's bigger than this, so it's kind of in the middle. And when we do this minimum thing, this will be isolated. So this will get popped, right? And while it's getting popped, because it's increasing, right? It's increasing. So if I encounter something that is the same, like if we have another 4, then this one basically doesn't take any space because it can convert them because they're within the same thing, right? So we don't have to consider consecutives. So now it's a 3. So this will get popped. So this definitely take 1. And then that's it. We just pop. So this one remain because this is bigger than this, right? So if you get a 2, then this will get popped. So this requires its own, right? But if it's a 3, then okay. So you're telling me that 1, 2, 4, how about 3, 4, 3, 2, 1, something like that. I don't know. So 3 will pop this, so it's +1, and 4, and then 3 will pop this, right? But this is the same, so I don't do anything. And then 2 will pop 1, don't do anything, and 1 will pop it, not do anything, and then the last will be +1. So it'd be 1, 2, 3, 4, 5. So we say it's 5. Let's see if it's right. Okay, our test case is 1, 2, 4, 3, 4, 3, 2, 1. Yep, I think that probably works. So in this case, 0 we just ignore. All right, 0 we just ignore. So it's just 2 by itself. And at the end, we always need to add 1. So this, yeah, this would be 3. 1 will pop this, so that's 1. 2, 1 will pop this, and then it's the same. We don't, it's the same. We stop, all right? Well, we can pop, but we just don't increment. So that's gonna be 3. Okay. Let's give that a shot. Monotonic array shall work, hopefully. All right. Yeah, I got distracted. It was a little bit work stuff. Okay, so we will use monotonic array for this. We know that any numbers, right, bounded by numbers, by smaller numbers, right? Smaller numbers form their own island, right, and cannot be removed along with cannot be removed with numbers outside the island. So monotonic array allows us to create, right, such islands in one path. Okay, so let's hope it works. I do need one. I mean, let's just do it. Mon, let's call it mon. And what we're gonna do is we will put things inside, right? You can say for int n of nums. Okay. Maybe we should have a rest as well. So what do we say? We say if n is equal to 0, then we'll skip. Actually, no. Because if n equal to 0, we'll just pop everything. Right? So no. We shall say while mon.empty if monotonic is not empty, right? And the same will pop as well, and then it's okay. So if it's not empty and n is smaller or equal to monotonic.back, right? So if n is smaller or equal to this, then int p we say mon.back, mon.pop back. You know what? Maybe we can just do a stack. Maybe stack will be faster. I don't know. Probably this is not back dot top, right? Then this is gonna be top, and this is mon.pop. Okay. All right. So we'll pop it, and because the current is n is smaller than that, and then we're gonna say if p is larger than n, right? P is larger than n, then rest plus plus. We can just say plus equal to p is larger than n. All right, and if it's bigger, then we'll pop, right? So I just realized that's because it's guaranteed it's monotonic increasing, so everybody should be okay. So if it's larger than, yeah, okay. So now once we get through all this, and then we will say if n is larger than 0, then we say mon.push. We push n in, but if n is 0, then we don't do anything. And then blah 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 blah. At the end, we'll return rest plus 1, because at the end of the day, oh, actually, rest plus it depends on if there's anything in a monotonic array. So we'll say mon.empty. Okay. If it's not empty, right? If it's not empty, then we need to do one more. But if it is empty, then we don't do it. So this is kind of just handle the situation of zeros. For example, we can have like that, right? In fact, we'll get some more zeros mixed in, just to make the scenario more complicated. Okay, so we are not correct in this, which is interesting. I think it's because at the end we have 1, 2 at the end. We shall use a 0. We shall use a 0 to push. So num stop push back, or push a 0 towards the end. Now if we put a 0 at the end, then we will get rid of everybody. So I don't think we need to handle this anymore. We just do that. shall work. Let's try this one. Yeah, I actually think this probably will work. Yep, I think it shall work. Not bad, not bad. It's late, I'm tired, but we got this one done. Not bad at all. Check the tutorial. Monotonic stack. Yes, it's exactly how we'd imagined it. Yeah, I was thinking about segment tree. You always think about segment tree. All right, that will be it. Good, 20 minutes, not too bad. I'll see you guys tomorrow. Adios.